Welcome to the presentation of the compressed air trade show exhibit. In factory automation, compressed air is the most expensive form of energy. Energy management, in accordance with ISO 50001, is therefore playing an increasingly important role. In order to save cost, you have to ensure that leaks are detected as quickly as possible. With the FTMg thermal flow sensor and the PAC50 Leakage Tester pressure sensor, SICK has the perfect solutions. We would like to show you in detail how this works with the help of our compressed air exhibit. A production line with a compressed air system is set up on the table as an example. The blue lines represent the compressed air lines from the compressed air generation to the individual consumers. The FTMg can be used both in the superordinate compressed air network as well as in the supply lines to the individual machines, shown by the blue circles. The PAC50 leakage tester is typically used directly at the end consumer or in separately containable areas of the compressed air network, such as you see here on a pneumatic gripper. In addition, with the MPSG, MZCG and MPS cylinder sensors, SICK is offering additional components for monitoring pneumatically operated systems. These are installed in the individual assembly lines but will not be presented in detail in this video.
We will start with the FTMg. The FTMg is mounted in the superordinate compressed air network in the exhibition model. The compressed air flows from the compressed air generation area through the FTMg with its inlet and outlet zones and is then distributed to the individual consumers. For instance, on a robot cell with a pneumatic gripper or a CNC machine. The individual consumers on the exhibition models are in constant motion and ensure that the compressed air is consumed. These fluctuations in the volume flow can be traced directly on the display of the FTMg. The exhibition model also offers the possibility of demonstrating large energy consumptions or leaks. In normal conditions, the compressed air flows through lines without leaks. But if you now press this push button, the air flows through a line with a leak. The leakage can be adjusted with the valve and the effect can be seen directly on the sensor display. The leakage is even more impressive when seen on the large touch display. On the dashboard you can see the volume flow and pressure. A leakage can be detected immediately since the volume flow moves into the red range. As an alternative to the push button, the leakage simulation can also be started directly via the display. In addition, the integrated web server of the FTMg can be shown by clicking on the web server button. Here we can see the actual parameters and the history of the last 7 days. A TDCE is installed in the exhibition model to demonstrate that the FTMg is ready for Industry 4.0. Via the TDCE, the data of the FTMg is transmitted to the SICK cloud in real time. Using the QR code, the customer can access the SICK cloud directly without having to dial into a network. This makes it possible to analyze consumptions and plan maintenance regardless of the location. Therefore, the FTMg is perfectly suited for condition monitoring and predictive maintenance. In order to present the industrial variant of the FTMg with switching outputs in addition to the Ethernet features, the touch display offers the option of presenting the FTMg marketing video.
A cost-effective alternative to the FTMg is the leakage tester version of the PAC50. As already mentioned, the sensor is intended for applications in smaller compressed air networks, separate areas of a compressed air network, or even individual machine circuits. The sensor can be used in 2 different operating modes. On the one hand, in its function as a normal pressure switch, with 2 switching points and analog output, and on the other hand, in its function as a leakage monitor. The latter case is to be demonstrated with the help of the exhibit. Basically, the built-in sensor checks a pressure drop over a certain period of time in the leakage mode. The duration of the measurement up to the time out was programmed into the sensor for this purpose. Likewise, 2 threshold values for the pressure range to be checked were already set in advance into the sensor. The command of a PLC to start a measurement can be simulated on the exhibit by pressing the center button in front of the PAC50 Leakage Tester. The other two lights to the left and right of this only signal the status of the gripper, means whether the gripper is extending or retracting. However, the leakage test can also be started via the push button on the touchscreen or by pushing the center button on the sensor. The preset time expires and the sensor checks the pressure drop and if the preset pressure switching thresholds are reached. If the values in the display stay green, everything is okay. If the color changes to red, both switching thresholds have been exceeded, which is an indication of a serious leakage. After the measurement time has been completed, the bottom line of the display alternately shows the elapsed time, the pressure difference and the leakage rate. In the large display of the exhibit, the user gets an indication of a leakage in percent. The percentage is related to how much of the pressure drop between the two threshold values is already lost.
As you can see, with the FTMg and the PAC50 Leakage Tester, SICK is offering comprehensive solutions for the efficient use of compressed air operated machines and pneumatic systems. Additional information on our products can be found on our website sick.com.